so we're going to go ahead and get started on section 3.2. This is polynomial functions. So last time we learned all about quadratic functions. If you, again, if you miss a class, remember that everything is posted on D2L, the videos from each day. So this is section 3.2, which is polynomial functions. I'm just going to tell you right now, I love polynomial functions. They're like one of my favorite things. So I'm going to get excited today. Okay, so what is a polynomial function? If you look on the packet I gave you last time, if you're on line, this packet is on D2L, I think. I'm pretty sure I posted it on Monday. Oh, wait just a second. I can't. A lot of things happened since then. Let me see. So let me open it up. Make sure it's there. So if you go into your section 1314 under content, it is week 6 we're in right now. There it is, documents, unit 2 notes. You can click on it there. That has the schedule for those of you on Zoom and all the printed notes for the this unit before your next exam. So, oh, and I'm glad I'm talking about this because so we're going through section 3.2 right now, but on Friday, I have this listed on Friday. I'm going to go ahead and extend it to Monday because I forgot to remind you on Monday about it, and I had it on my list to email you, and I forgot that also. So comp exam attempt number 2, we're going to make that due on Monday. Okay, so make sure you're attempting your attempt number 2. If you're happy with grade from attempt number 1, that's fine. You don't have to do attempt number 2 or 3, but you get 3 attempts. If you're not happy with grade number 1 or the grade from attempt number 1, you need to do it again. Okay, so I'm going to extend that deadline until Monday at midnight for attempt number 2. The password for it is, to get into it, is ready to, R-E-A-D-Y, even though it does not look very good. Ready to, and remember that you complete all of your work on your own paper and you upload that into, it's an assignment and it's called attempt number 2. I think it's comp exam attempt number 2. And don't forget to make that a PDF document. Okay. You also need to upload the honesty statement, and I have all this on D2L. Okay, so if you go to comp exam work, comp exam work, there you go. Comp exam work attempt number 2. This is where you're uploading it at. It says it's due, well, it'll be due on Monday, whatever Monday is, the 5th. I'm gonna change that to the 5th, is whenever it's gonna be due at. Okay, so make sure, and if you don't remember how to make PDF, you can click on the PDF video, and the honesty statement should be included here also. I'll include it just in case. I'll go back in and make sure it's included if you don't see it there. And you can use your honesty statement from last time. Just mark out the date and put the new date on it, and you can submit that. That's fine also. Questions about that? Okay, so make sure that you are getting that turned in for those who did not, or if you're not happy with your grade from comp exam attempt number 1. Okay, so anyways, well, I got this whole thing out. I'm glad I remembered to do that, to talk about that. But it's to talk about polynomials. The first section was, this was all the information we went over last time. A polynomial function, though, here's the mathy definition for a polynomial function. Basically, it's just a function of degree n, and all exponents are positive integers. That's the big deal right there. A positive integer. What's an integer? Do you know what an integer is? Whole number. Positive or negative. Integer technically could be a positive or negative whole number. This is specifically positive whole numbers. Okay, so polynomial is any equation that has x's with positive whole number exponents. Okay, So we're looking for positive whole number exponents. That's the big deal here. So let me give you some examples. Whole number exponents. Some examples and non-examples. So examples are, if I had f of x equals negative 3x to the 5th plus 2x squared plus 5. That is a polynomial because what are my exponents here? 5, 2, right? Those are both positive whole numbers, so they are, that is a polynomial. Okay, you could even say what we did last time, 3x squared minus 2x plus 5, a quadratic. Is that a polynomial? Does it have positive whole number exponents? Yeah, it does. So that is also a polynomial. A quadratic is a very specific polynomial, but it is still a polynomial. What about a linear function? 2x plus 3. Is that a polynomial? Do you have positive whole number exponents? Yeah, technically this is a 1, right? So technically a linear function, it's a weird one, but it's technically a polynomial function also. Things that are not a polynomial function, so non-examples here, are things that do not have positive whole number exponents. For example, if I had 3x to the 1/2 power plus 2x squared. That is not a polynomial function because I have x to the 1/2 power. Another example, if I had 3 over x squared plus 2x. Why is that not a polynomial function? What's the exponent for the x squared? It's a 2 on bottom of a fraction, which makes it -2. Technically, if you wrote it, it would be like 3x to the -2 plus 2x. And that's a negative number. So that's the reason why that is not a polynomial function. We kind of actually talked about that already. Yeah, because you can't have 0 on bottom. It's a rational function. We'll learn about that after polynomial functions. Okay. This x to the 1/2 power, do you remember how you could write a different way you could write that without an exponent? Yeah, x to the 1/2 power means square root. So you could also see this written as 3 times the square root of x plus 2x squared. Basically, if there's anything funky in there, if it looks weird, it's not a polynomial function. Polynomial functions are very straightforward, look like normal. Okay, so let's talk about the degree of polynomial functions and leading coefficients. Degree. I think we kind of talked about this a little bit last time, but let's continue talking about it. The degree of a polynomial function is the highest exponent term, technically. It's technically the highest exponent in your function. The highest exponent in your function. Okay, so let's go back to those first 3 problems. What was the degree of the first function? 5, because 5 is the highest exponent. It has degree 5. What's the degree of the next function? 2. And the degree of the first one? Or not first one, last one, 2x plus 3. Degree is 1. Okay, so degree tells us the specific type of function it is. It also tells us 3 other major things we're about to learn about. We're not quite there yet, so give me a second. What about if I had the function, I'm going to add this one in here, h of x equals 5. This is like a tricky one. Is that a polynomial function? Do I have an x there? I mean, you don't see one, but technically, could you write an x there? X to what power? X to the 0 power, right? Because x to the 0 power is just 1.
So technically this is x to the 0 power. Is 0 a positive whole number? Yeah, it's kind of neutral, but technically, yes, it doesn't disagree, right? It's not a negative number. It is not a not whole number. So a function like this technically is a polynomial. What's the degree here? 0. This has a special name. What does this look like? Y equals 5. It's a horizontal line, right? This is called a constant function because it doesn't change. It's always 5, right? Like you always get the answer 5 out of for it. So this is actually a constant function. Constant functions have a degree of 0. They're just plain old horizontal lines. There's not much to them. We don't spend any time on it because there's nothing to do with them. It's just 5 or just whatever your number is. Okay, so polynomial functions. One thing about polynomial functions is they have smooth and continuous graphs. So we talked a little bit about continuous graphs before. Remember when we were talking about domain and range, when we did the domain of that step function, the step function was the one that had the line and then the line and then the line and then the line. It had a continuous domain there, right? It went from, I don't remember the specific numbers, from like 0 to 5 or whatever. But it jumped up and down. It was continuous, but it wasn't smooth, okay? So here are some examples on your notes sheet. Here's some examples of smooth continuous graphs over here. If you'll notice, they curve, but they're smooth. They don't stop anywhere. The domain is negative infinity to positive infinity. Okay, look at this other, was W-shaped one. That's a smooth and continuous graph. This one right here is not a graph of a polynomial function. Technically, it's continuous. I mean, there's a break in the graph, but there's like a jump here, right? It's not smooth and pretty. If you look at this one, this is continuous also, but is it smooth? There's jagged edges, okay? So you're not gonna have any jagged edges at all. It's just gonna be like all these loop-de-loos basically for your graph. Okay, so degree, before degree, let's talk about the leading coefficient. What's a coefficient? You got this. The number before the x is a coefficient, okay? So the leading coefficient is when your function is in descending order, which is what we're used to. Descending order means your exponents go from highest to lowest, like this one. These are all in descending order. Negative 3x to the 5th, 2x squared, 5. 3x squared, 2x. This is a constant, or x to the 0 power, right? Okay, so these are all in descending order. If it's in descending order, your leading coefficient is the first number in your equation, the first number before your highest exponent variable. Does that make sense? So for the first problem, what's the we usually say LC for leading coefficient. What's the leading coefficient for the first problem? Negative 3. What's the leading coefficient for the second one? Positive 3. What's the leading coefficient for g of x? 2. Okay, so it's just the number in front of your highest exponent variable. Okay, the one that tells you the degree, it's the number in front of it. Okay, degree tells us 3 things. Okay, the first thing degree tells us is it tells us about the end behavior. Okay, so the whole goal of this lesson is to be able to graph a polynomial function. So we're going to talk about all the things you have to look at an equation for to be able to graph it. So the first thing we're going to talk about is end behavior. So end behavior is the arrows at the end of your graph. Okay, because remember these have continuous domain. The domain is negative infinity to positive infinity for all of these. So they're going to have arrows at the end of the graph. So your graph could look something like that. Your graph could look, I mean, like a quadratic, right? It could look lots of different ways. End behavior is specifically this part and this part, the arrows at the ends. We can describe the end behavior as rising or falling, okay? So we talk about the left and the right. So for this first example right here, does this rise on the left or does it fall on the left? falls on the left. Does this rise on the right or fall on the right? Rises on the right. Okay, it's decreasing on the left-hand side. Well, no, don't use decreasing. It's technically increasing. Just the way the textbook talks about it and Math Excel talks about it is rises or falls. Okay, falls on the left, rises on the right. Look at the second graph. What does it do on the left-hand side? Rises on the left, rises on the right. Okay, so you're either going to use falls or rises to describe the end behavior. The degree tells us what it does. Okay, so the degree tells us about end behavior. Specifically, is if your degree is an even number or if your degree is an odd number. If your degree is an even number, that tells us that our end behavior does the same thing on both sides. Okay, so end behavior, I'm going to put EB for end behavior, goes together is kind of how I think about it. They either, both arrows either go up or both arrows go down.
So I don't know who the commentator's name is. It might have been.
Okay, so degree, if it's an even number for your degree, both of your arrows go up, both of your arrows go down. This is the one that should make sense in your head because we've talked about quadratic functions. What's the degree of a quadratic function?
I didn't know there was another person running for president, honestly. I didn't know.
You got this, come on. What's the degree? 3x squared minus 2x plus 5, what's the degree? 2. Quadratic functions are even degreed functions, right? Because they have a degree of 2. What do quadratic functions look like? Parabolas. They open up or they open down, right? Look at do your arrows always go the same direction, both up, both down? Yes. Okay, so even degreed functions, the arrows go together up or the arrows go together down. Okay, odd degree functions. What do you think these do? Go opposite. One goes down, the other goes up, or vice versa. The first one goes up, the second one goes down. Okay, so end behavior is, I say goes opposite.
Better credentials than either of them.
So it could fall to the left and rise to the right, or it could rise to the right and fall to the left.
He does. You know the kindness that comes out of some people.
So this would be like x to the third power is your highest exponent, or x to the fifth power is your highest exponent, or super easy, straightforward example, the lowest odd number is 1. What kind of function has a degree of 1? Linear functions. Don't lines go opposite directions? Like if you look at your end behavior on a line. Okay, so the question is, when does it go this way? When does it go this way? Or for parabolas, when does it go up? When does it go down? Let's use our parabola knowledge to come up with the answer for this because we just did this on Monday. When do parabolas open up and when do they open down? If your A value is positive or negative. That's what we talked about on Monday, right? If A is positive, they open up. If A is negative, they open down. In this situation, what did we call that A value? The leading coefficient, okay? If your leading coefficient is positive, they open up. If your leading coefficient is negative, it opens down. So this is a positive leading coefficient. This is I wrote it wrong, negative leading coefficient. It opens up if it's a positive leading coefficient. It opens down if it's a negative leading coefficient. If you understand quadratics, you don't even have to memorize this, right? Like you already have this memorized at this point. Odd functions. Let's think about linear functions, okay? Same idea. It's one way if your leading coefficient's negative versus the other if your leading coefficient's positive. Let's think about for linear functions. For linear functions, your leading coefficient is what in that situation? Like it's 2 in this problem. What does 2 represent for this line? The slope. Positive slope goes which way? The first one or the second one? The first one's positive slope. The second one's negative slope. Does that make sense? So this is a positive leading coefficient. This is a
Right.
negative leading coefficient.
People were scared of.
Does that make
condos
sense?
at that time.
It's
Running
called the
away.
Red
There is a
Scare.
table if you like tables. Okay, it's in your notes. This is essentially what we wrote already. If it's an odd degree, they go opposite. If it's a positive leading coefficient, it looks like that. If it's a negative, it looks like that. Even degrees, positive leading coefficients go up, negative leading coefficients go down. So here's like a little table if you want to memorize that table. Okay, we're gonna take a second and we're gonna, this is gonna be weird doing on Zoom, but let me stop sharing. Let me start the video. Uh-oh. Let's see if it'll do it.
So it was more,
World War II was Germany, Japan,
Our video.
and
There we go.
I think there was one
Okay, so we are going to describe or show the
Italy.
in behavior of things
more.
using our
Yeah,
arms.
they hung
Okay,
loose
so
things
everybody
about
show
that
me
piece.
even
And then
degree
Stalin-
positive leading coefficient with your arms. Even means they go together, positive means they go up. You think it's dumb, but you're gonna be on your test and you're gonna be glad we did this. Okay, even in behavior with a negative leading coefficient, they go down. Even your arms go together, right? Okay, even, nope, odd degree positive leading coefficient. I gotta go this way because I can't think. Goes like that, right? Oh, on Zoom, I think it's flipped around. Dang it. Sorry, guys. And what's the other one? Odd degree negative leading coefficient. If you're in class, it looks like this, and it's backwards on Zoom, right? Isn't it backwards? Sorry, people on Zoom. I tried. Okay, so just try to remember, let me switch back. Try to remember that even goes together, odd goes opposite. And if you really think about just like slope, positive slope versus negative slope, that helps out a lot. Okay, so that's one thing that the degree tells us is end behavior. Let's do just one problem, how this is gonna look on your homework. Let me make sure that they're not telling me that it's in the wrong spot or whatever. Are we back to normal? Can you see now? Oh, dang it. Okay, so some of the problems would look something like this. What did you say? Describe the end behavior. Okay, so if I had the problem, f of x equals, we're going to do two different problems here. We're going to, because sometimes they show it in two different forms. Okay, so if I had negative 3x to the 5th plus 5x to the 4th minus 2x to the 3rd plus x squared plus x minus 2. That is a very long polynomial function. To be able to describe the end behavior, you have to know two things. You have to know degree, leading coefficient. What's the degree here? The degree is 5 because it is the highest exponent. What is the leading coefficient here? -3. Okay, so I don't actually need to know the specific numbers. I need to know if it's odd or even and negative or positive. So is the degree odd or even? Odd. That tells me my arms are going different ways. This way or this way, right? The leading coefficient sign tells me which way it goes. Is leading coefficient positive or negative? It's negative. So odd, negative, arms go opposite directions, and it needs to look like negative slope would be that way, right? That way. So it's going to look like this. I'm fine on your test, you giving me this as the answer. Math Lab's not going to let you put in 2 arrows as your answer, so you have to describe it. What does it do on the left? It rises on the left. It falls on the right. Okay, the other problem I want to do is when the polynomial is not multiplied out and written in like the standard form like this, when it looks a little different. Okay, so what if I had the polynomial that looks like this? -4 times x minus 1 to the third power times x plus 5. Okay, are we physically capable of multiplying it all out to getting this big long thing? I know we can do it. Let's talk about how, we're not going to do it. Let's talk about how you would do it. X minus 1 to the third power. That means multiply x minus 1 times itself 3 times. It's going to take a while to do it, but we could do it. And then you multiply that by x plus 5. So you got to distribute all that. And then you multiply by -4. I mean, it takes us like 5 minutes minimum to do that. Okay, you can do that. But what is really the only thing I need from this whole equation? The degree and the leading coefficient, which is technically just from the first term. Okay, so technically I can get the first term just by multiplying the first of everything here. Okay, so -4, first equal sign, it'd be -4 times this term right here, x to the third power, because this parentheses is raised to the third power, so times x to the third power, times here, the first thing in this set of parentheses is x. Does that make sense? You do the number, the coefficient out in front, the x to the power, x to the, this one didn't have a power, but if it did, I would do it to that power also. Okay, so we're going to multiply this together. What is -4 times x to the third times x? -4 x to the fourth. That is your first term. Okay, so from that, what's my degree? The degree is 4. What's my leading coefficient? -4. Is the degree odd or even? Even. Is the leading coefficient positive or negative? Negative. So what do even functions do? Go together. Negative tells us they go together down. So that would be my answer. Or if you used words for it, it falls on the left and falls on the right. Questions about that? Does that make sense? That's how you do in behavior. Okay, so degree tells us 3 things. It tells us in behavior, you use the degree and the leading coefficient to tell you what your in behavior is. The second things it tells us is the number of solutions that you have. Okay, so the next thing degree tells us is the number of solutions. Okay, so solutions in this situation go by a few different names. Solutions also have the name of, anybody know another name for solutions? When you solve like a quadratic? What? There's zeros, What's another name for that? Where do you see them at on your graph? They're x-intercepts. And there's one more word for them. Roots. All of those mean the exact same thing. Roots, zeros, solutions, x-intercepts. Okay, so you literally could have 4 problems. One problem saying find the solutions, the next one says find the zeros, the next one says find x-intercepts, the next one says find the roots, and they all mean the exact same thing. Okay, so solutions, roots, zeros, x-intercepts. The degree tells us how many solutions you have. So the degree is the number of solutions you should have. So for a quadratic, how many solutions should every quadratic have? 2, because the degree is 2, right? This problem number 1 on the in behavior, how many solutions does this one have? 5. How many solutions does number 2 have? 4. Okay, so the degree tells us how many solutions we have. Okay, so I'm going to go ahead, before I spend the time on the solutions, I'm going to go ahead and talk about the third thing the degree tells us real fast, just because I feel like it's going to get glossed over if we didn't. So that's like the second thing the degree tells us. The third thing the degree tells us is the max number of turns. The maximum number of turns. Okay, and the maximum number of turns actually is the degree minus 1. So take away 1 from the degree, and that's the maximum number of turns that graph can have. This should kind of make sense, because for a quadratic, what's the degree of a quadratic? 2. The highest exponent on a quadratic is squared, so it has 2 for the degree. So it has 2 solutions. What's the maximum number of turns a quadratic can have? What's 2 minus 1? 1. So a quadratic has degree 2. The max number of turns it has is 1. And doesn't that make sense based on every graph of a quadratic? What's every graph of a quadratic look like? A parabola. How many turning points does it have? 1. It's down here at the bottom. What's the name of that turning point? The vertex, right? So it has 1 vertex, which is the turning point. Okay. Again, this is not, when we get into bigger functions, like bigger than degree 2, when we have like degree 5 and degree 8 and that sort of thing, it doesn't mean it for sure has that many turning points. That's just the maximum it can have. It can't have any more than that number. Okay. So if you had a quadratic and you ended up with 3 turns on it, you did something wrong, because it's not going to work out that way. Okay. So let's talk about how to find, let's go back to solutions, zeros, x-intercepts, roots. Let's talk about how to find the solutions, zeros, x-intercepts, or roots. How do you find them? X-intercepts means plug in 0 for y, solve for x. So how to find the x-intercepts is plug in y equals 0, solve for x. This is the hardest part of this whole topic we're going over right now. Today, we're going to go over the easy ones. Friday and Monday and Wednesday, we're going to learn how to do the hard ones. Okay, so let's start off with this first example. F of x equals x to the 3rd power plus 3x squared minus x minus 3. Okay, what is the degree here? 3. Is it an even degree or odd degree? Odd. Does it have, what's the end behavior? Well, first of all, leading coefficient, is it positive or negative? Positive. So positive odd is positive slope, right? Okay. So the end behavior here looks like this, because the degree is 3, positive leading coefficient. And I need to solve this. This is not a quadratic, so I cannot use quadratic formula here. First of all, I guess I need to plug in 0 for y. If you plug in 0 for y, you get 0 equals x cubed plus 3x squared minus x minus 3. Okay, so sometimes we can factor these. Not always, usually not very often actually, but sometimes we can factor it. Can you factor this one? you were going to factor it, how would you factor it? Grouping. That's the only way I have to factor this because it's 4 terms. So let's see if it factors by grouping. On the first two, x cubed plus 3x squared, what's the GCF? X squared. Left over is x plus 3. For the second two, I can take out a -1. Left over is x plus 3. So then pull out an x plus 3, and left over is x squared minus 1. How do I solve by factoring? Set each piece equal to 0 and solve. Okay, so I have x plus 3. Okay, 2 ways I can do this. I can set it equal to 0 at this point and solve that one using square roots, or you could actually factor that one. What does x squared minus 1 factor into? It's the difference of 2 squares. So you could do this as x plus 1, x minus 1 if you wanted to. Let me show you if you forgot how to do that. Or if for some reason that one didn't factor. It'd be x plus 3 equals 0, x squared minus 1 equals 0. When I solve it, subtract 3, I get -3. On the other one, you're adding 1 to both sides. You get x squared equals +1. How do I solve for x? Square root, don't forget the plus or minus. So I get x equals positive or negative, what's the square root of 1? 1. So it's +1 or -1. Do you see how you get the answer either way? So my answers here are -3, +1, -1. How many answers should I have had here? 3, because the degree was 3, right? I got all 3 answers right there. What's the maximum number of turning points here? 2. Okay. Starting to kind of get the idea of how to do this. Okay, sometimes you work it out and you only get, like here I knew I had to get 3 answers. Sometimes you only get 2 answers, or you only get 1 answer. And let's talk about what that means if you only get 2 answers and 1 answer. And that'll probably be where we are going to end at today. So let's do one more problem that doesn't work out quite as nicely. Okay, so it still factors though, at least. F of x equals -x to the 4th plus 4x to the 3rd minus 4x squared. Okay, to solve, we're going to set it equal to 0 first. 0 equals -x to the 4th plus 4x to the 3rd minus 4x squared. As of now, the only way you know how to solve this is by factoring. That kind of looks like AC method, but it looks weird. What can I do to fix it? Yeah, it has a greatest common factor of x squared right now. And technically, let's take out a -x squared. So I'm going to get -x squared when I pull out a GCF of -x squared. -x to the 4th divided by -x squared is x squared. 4x to the 3rd divided by -x squared is -4x. And -4x squared divided by -x squared is +4. And then now that inside part factors using the AC method. A is 1, C is 4, so AC is 4. What things multiply give me 4? 2 and 2, right? So this factors into -x squared out front, x plus 2, x plus 2. Thank you, -2, my bad. -2, -2. Okay, so now how do I solve for x? Set everything equal to 0. So I get -x squared equals 0. X minus 2 equals 0. X minus 2 equals 0. So for this first one, to solve for x squared or solve for x, I first need to get rid of the negative. How do I get rid of the negative? Divide by -1. It doesn't matter because it's 0 anyway. So I get x squared equals 0. How do I solve for x? Square root both sides. Don't forget your plus or minus to get your two answers. So I get x equals positive 0 and negative 0, which is dumb because it's just neutral, right? Not positive or negative, essentially. But that's my two answers there, 0 and 0, right? For the first one, when I add 2 to both sides, I'm sorry, for the second one, I get x equals positive 2. For the third one, when I add 2 to both sides, I get x equals positive 2. How many answers was I supposed to have for this problem? What's the degree of this problem? The degree of this problem is 4. I should have 4 answers. Do you see where the 4 answers are? Kind of. X equals 2 is one of the answers. X equals 2 is another answer. 0 is an answer. 0 is an answer. So technically that's 4 answers, right? Really, how many answers did I have though? Just 2 and 0. When you look at a graph of this, you're only going to see 2 solutions, but 2 of them are the same here. 2 of them are the same here. This is called multiplicity. And this is a very important idea, multiplicity. Okay, so multiplicity essentially is how many times you have a number as an answer. Okay, so the reason why we talk about multiplicity is the way you would write this answer is I have x equals 2 with a multiplicity of how many times did I have that answer? Wait, multiplicity, sorry. If I had the answer 1, 2 times, so it has a multiplicity of 2. The other one is x equals 0. How many times did I have 0 as an answer? 2 times. So it also has a multiplicity of 2. And you can abbreviate. You can say MULT 2. So the multiplicity is how many times you got that answer. You still have to tell what the answer was. So your multiplicities technically should add up to be your degree. Does 2 plus 2 equal 4? Yes, I have my 4 answers here. Okay, the reason why multiplicity is important is because it tells what your x-intercept does on the graph. Okay, where do we see x-intercepts on the graph? Where do you find an x-intercept? On the x-axis, right? So technically, looking at this weird graph I did before, how many x-intercepts does this one have? 1. Okay, how many does this one have? Technically none. These were imaginary, right? What if I drew this a little different? Let's say this actually touched like that. How many x-intercepts do I have here now? 2. Look at the difference. This one goes through and this one bounces off. That's multiplicity, whether it goes through or whether it bounces. Okay, so multiplicity tells us what your x-intercept does on the graph, whether it goes through the graph or whether it bounces on the graph. And it's based on if your multiplicity is even or if it's odd. If your multiplicity is an even number, so even number multiplicity tells us that your graph touches and turns or bounces off the graph. Okay, so I always think, I think on your textbook and everything, it says touches and turns. And odd multiplicity, odd number multiplicity, crosses through your graph or your x-axis. The way, oh goodness, the way I remember this is touches and turns, there's 2 things happening there, and that's an even number. Crosses, there's 1 thing happening in there, and that's an odd number. That's how I remember it in my head. Okay, we're not quite there yet to where we're ready to like straight up graph one, but we're not gonna really move on to another problem after this. So I just wanna like apply this to a graph, this problem we just did. Let's just kind of sketch the graph of it. Technically, we don't have everything we need to know yet, but I want you to be able to put it all together in your head at this point. So the graph of this one, we said it had a degree of 4. What's the leading coefficient here? -1. So is it an even degree or odd degree? even, that means my end behavior goes together. Is it negative in behavior, or negative or positive leading coefficient? Negative. So what does my end behavior do? Both goes down. Even goes together, negative goes down. Okay. So my end behavior here is this and this. Technically, I'm going to have an arrow going this way and an arrow going this way, right? I also have x-intercepts. I have an x-intercept of x equals 0 with a multiplicity of 2, and x equals 2 with a multiplicity of 2. Okay, so it's going to touch the x-axis at 0, possibly cross it. We'll figure that out in a second. It's also going to do that at 2. Is our multiplicity odd or even here? It's an even multiplicity. So that tells me at each of these x-intercepts, it touches and turns. So it's going to bounce off the x-axis at both of these dots. The question is, does it bounce up or does it bounce down? End behavior tells us that, okay? Because it's got to go this way for that side. It's got to go this way for that side because that's the end behavior. So that means it has to bounce here. It has to bounce here, and it meets somewhere in the middle. That's the part we haven't learned yet, okay? We'll get to that part later. So it looks something like this. It's like a upside, or like M-ish shape graph. And you could technically, let me get a calculator, put it on a calculator and look at it. Come on, and check it. The graph of this function is negative x to the 4th plus 4x to the 3rd minus 4x squared. Oh, wait, my graph is messed up. Just a second. Sorry. Let's try that again. Negative x to the 4th plus 4. Plus 4x to the 3rd. Sorry, minus 4x squared. There we go. Come on. There you go. So that's what your graph looks like. Okay, we will continue this lesson on Friday. Make sure you're doing your comp attempt and make sure you're working on your homework, and I will see y'all next time.